So now we're back and we're going to actually start getting into how to approximate. And again, in this lesson, we're only going to be approximating the instantaneous rate of change using some algebra. So we're going to be looking at the function 3 plus x squared, and we're going to try to find the instantaneous rate of change with x equals 2. Okay, so what does this graph look like? Well, we know that 3 plus x squared looks like this. And when x equals 2, my function evaluating that is 7. And what I'm going to do is I'm going to choose 2 points. I'm going to choose the point 2 plus h, and then, well, 2 minus h. And we're going to look at the average rate of change between here for 2 and 2 minus h, and the average rate of change here for 2 plus h and 2. And in both of those cases, the slope is going to be, well, in the first one, we're going to have f of 2 plus h minus f of 2 all over 2 plus h minus 2. And the h will, sorry, the 2's will go away, so there's just an h. And so that should start looking very familiar to this case up here. And so we've got instead of the a, we've got 2. Instead of the a, we've got 2. So we're looking at the instantaneous velocity of 2, and we're going to do that by letting h get close to 0. But in our case, the way that we're going to let h go to 0 is we're going to say that h can be 0.1. So h is 0.1, making it 2.1. Or h is negative 0.01, or in other words, let's choose the 0.1 at 1.9. So if we're letting h equal 0.1, this case here, the approximation of the instantaneous rate of change would be f of 2.1 minus f of 2 all over 2.1 minus 2. Now we can evaluate f of 2.1. In fact, let's just show how we would do that on the calculator. If we bring up the calculator, and in my calculator I've got the graph y equals 3 plus x squared, and I can just do second calc value, second calc value when x equals 2.1, and we find out that y is 7.41. So we've got 7.41 minus f of 2. Well, f of 2 we know is just 7 all over 2.1 minus 2. And this simplifies to 4.1. That's what h is 0.1. When h is negative 0.1, now we're looking to the left of 2. Now we're looking at, this point and this point when x equals 2 and when x equals 1.9. So when h equals negative 0.1, the slope that we'd be looking at is f of 2 minus f of 1.9 all over 2 minus 1.9. So we need to find out what is f of 1.9. So going to our calculator, I can go second calc value when x is 1.9. We know that my function is 6.61. So we know that f of 1.9 is 6.61. So this will equal f of 2, which is 7 minus 6.61 all over 2 minus 1.9. And this equals 3.9. So when h equals 0.1, our approximation approximation of the instantaneous velocity was 4.1. When h equals negative 0.1, our approximation was 3.9. They're very close, and to get an even better approximation, let's find the average of the two. So a better approximation would be the average of my first one, when h equals 0.1, plus my second one, when h equals negative 0.1. Find their average. And this is that our instantaneous rate of change when x equals 2, our instantaneous rate of change, we're approximating to 4. It is, in fact, exactly 4. So what we did is we let h be a small number, 0.1, and then an equally small number, but negative 0.1. And we evaluated our slope equation. So what we really just did is we found the slope between when x equals 2 and when x equals a number really, really close to 2, 2.1 and 1.9. And so we found the average rate of change, but we're calling it the instantaneous rate of change because the distance between those points was so small. Okay, so now we're going to approximate the derivative. The derivative is just the instantaneous rate of change. So we're going to find the instantaneous rate of change, and we just did this at 3 plus x squared at the point. So we're just finding the derivative at this point at x equals 2. So we know that it should be close to 4. Whatever we get should be close to 4 because that's what we found in the previous example. It's the same function at the same point. We're finding the instantaneous rate of change. And so the idea is this. The idea is that if we take any curve, no matter how curvy it is, and we zoom in on a section, so we're going to be zooming in on this. As you zoom in, every curve is going to become straighter and straighter and straighter. Almost every curve. Some do not, but for now, each of the curves we're going to be looking at is going to become straighter and straighter and straighter. So let's show what I mean by that. So if we take our graphing calculator once again, and here's our curve, and what I'm going to do is I'm going to zoom in right around x equals 2, and just so I can get right at the right point, I'm going to press second trace, go to value when x equals 2, and now I'm going to zoom in again. So second, zoom, or just zoom, go to zoom in, and notice our line is becoming straight. It's pretty much perfectly straight now. So once our line becomes straight, and I wrote this a little bit poorly, not just poorly, incorrectly. This should say zooming in on the graph until the curve becomes straight. So it has become straight, and so now what we need to do is we need to choose just any 2 points on this line. So the first point that I think makes the most sense to choose, is the point that we're talking about. So when x equals, the second calc value, when x equals 2, we know y equals 7. So I'm going to take a picture of this. Hopefully take a picture of this. Okay, so now we have a picture of the straightened curve, and we've got the point 2,7. And so now let's go back to our curve, and we need to choose another point on that. So let's just trace this curve and choose some other point. Let's choose this one, for example. So now let's take a picture of this so that we can capture it. So taking a picture of it. Okay, so here we have 2 points on that curve, and we have straightened that curve out, so now we know that we're talking really about this tangent line. So we zoomed in on this curve until it became a tangent line, and the slope of a tangent line is the slope of a tangent line is the instantaneous rate of change. And so now I have 2 points. I've got 2, 7, and this kind of rougher point that are 2 points on this curve that are on the tangent line. And so to approximate the derivative or the instantaneous rate of change, I'm just going to use slope again, and let's round to 2 decimal places. So I've got my slope would be 7.03 minus 7 all over. Now we need to round a little bit. 2.01 minus 2. And if we now evaluate this equals 3. Now, everything we've done is good. It's not 4 like we thought, but a lot of that comes into rounding errors. And if we were to go and use all of these digits, we'd be much closer. But as far as our approximation goes, this is close enough. And the idea is we took a curve, we took our y equals 3 plus x squared, and we zoomed in when x equals 2 until the graph became straight. And once it became straight, like it did here, we chose 2 points by just tracing, and we use these 2 points to find the slope between those 2 points. And that's it for this lesson. And this has all been about approximating instantaneous rates of change. And so we did it this method by zooming in on the curve. We use this method over here where we let h be a really small number. We approximated h, which is our distance from the point we're interested in. We approximated it at 0.1 and negative 0.1 and found the slopes that way. And the other method that we looked at was that was earlier. We were looking at drawing tangent lines and approximating that. So that's what we did. We were looking at approximating the derivative, and the derivative is the instantaneous rate